Dear students, we are going to solve quiz number 1, partial differential equation. Course code is MTH 646. The most repeated question of first quiz we are going to discuss. The first MCQ is, if numerical scheme is unstable during solution procedure, then the result becomes unbounded. Number second is, if numerical scheme is unstable, result becomes unbounded, reaching overflow and independent of choice of computing system. The third one is, instability arises when numerical procedure itself tends to amplify error to the point that amplified error obliterates the solution. Number four is, stability analysis can be performed with Fourier method. Number five is, Fourier analysis is performed by expanding solution in space Fourier components over discretizations. Number six, numerical scheme is unbounded if the condition is G mod greater than 1. Number next is, numerical scheme is unbounded. Condition for unbounded was G is greater than 1. Now condition for boundedness is G mod is less than or equal to 1. Number 8 is, Fourier mod is expressed as Fwix is equal to Wx exponent I. Okay, keep in mind here we have Wx is equal to amplitude mod, while I is imaginary mod, and the sign for the ohm is Fourier mod, and the entire equation is for matrix norm method. Number next is, consistency and stability are necessary and sufficient condition for convergence of algorithm as time steps approaches to zero. Small changes in initial data correspond small changes in result. If a procedure satisfies this property, we call it stable. Otherwise, it will not be stable. Some procedures are stable for certain choice of data of initial condition, but not for all choices. Then we have finite difference equation is convergent when u tends to at fixed point u or mod capital U minus u approaches to 0. Number next is, partial f by partial t plus c partial f by partial x is 0. If c is greater than 0, a backward difference is used in space, and if c is less than 0, forward difference is used. Then we have the equation f I to j plus 1 is equal to f I to j minus c del t by del x into f I to j minus f I minus 1 j is known as upwind scheme. The number next is, g is equal to gk. It is called amplification factor and it is always a complex number. In the same way, I is equal to under root minus 1 is imaginary number and k is called wave number and generally a real number it is. And we are talking both I and k in equation f from I to j g power j e I k x, and we call it Van Neumann equation for independent solution. Number next is Laplace second degree differential equation is partial square u by partial x square partial square u by partial y square. It can also be written as uxx plus uyy equal to 0. Now u I j u I minus 1 j plus u I plus 1 j u I j minus 1 u I j plus 1 whole by 4. It is called 5-point formula. Then we have, if we rotate theta equal to 45 degree, then same 5-point formula becomes diagonal 5-point formula. Number next is Poisson equation in two dimension is partial uxx plus partial uy, sorry, uxx plus uyy is equal to minus 2, or it can be x e bar y. Don't forget to subscribe the channel. Thanks for the watching.